A couple of videos ago, we talked about the first derivative test for Extrema. Now that we understand concavity, we can talk about the second derivative test. So suppose we know that the derivative at a place is 0. So it's a critical point, and we'd like to know whether it's a max or a minimum. So if the first derivative is 0 and the second derivative is positive, well then what that would mean is you'd have a slope of 0 and it would be concave up. And so of course that would be a minimum. If first derivative is 0 and the second derivative is negative, well then of course you have a slope of 0 and it's concave down. So there you have a relative maximum. And of course, what if they are both 0? Well, then you get this strange case where you're getting both a point of inflection as well as a slope of 0, and a bunch of things could happen here. So for example, it could change concavity. So for example, with a cubic function, y equals x cubed, you do get a slope of 0 right there at the origin, but because it's increasing before and after, it's not a max or a min. Or, say with this curve, y equals x to the fourth, well this curve also, the first derivative is 0, the second derivative is 0 at the origin. Well there we're getting a slope of 0, and actually we're also getting a moment of no curvature either, but then it goes back to being concave up. So in fact it's concave up both before and after that, and so it winds up being a minimum anyway. In fact, that is the absolute minimum of that particular curve. So more analysis is required when both the first derivative and the second derivative are 0. But if the first derivative is 0 and the second derivative is non-zero, immediately you're able to tell whether it is a max or a minimum.